This conference will now be recorded.
Okay, thank you. So our main agenda for the today's discussion is volumes, right? Volumes, and in that we will discuss majorly about the persistent storage, and we'll also discuss about some part of the storage class. Okay, so but in the last session we had one question that one question was nicely raised about what is a there is a in the when you create any pod there are two containers get created, and out of that one is your actual container which holds the application, and there is another container which is in the pause state, right? So what is the meaning of that pause state container? So let me give a 2 minutes briefing on that one, and then we'll go for the volume management. So this is, let's say, your pod which get created. When we create a pod, this is actually your main container, right? And then along with that, it also creates one container that is called as pause container. This is your pause container. So it is similar like you can say a sidecar container. But what is the use of this pause container? Basically, if you want to start any container which you have seen in the Dockerization, you need to there should be some process IDs or some parent process ID should be running. So if you want to start any container, that container should be running with some parent ID. That is called as the process ID, parent ID. If the parent ID is not there, then container it stops. So what happens here, guys, when we create a pod? So to start the container inside that pod, you have to have one container. This is sidecar container, which act as a parent container for the actual container. So first of all, your pause container will start, and then then your application container will start, and then it will go into the pause state, right? And so in case if you are creating a different replicas, or if something goes wrong with this container, that container can be again brought back with the help of some replication controllers. And that time your pause container will be helpful for you, right? So pause container is a container which is used as a which is used for starting the container, and it acts as a parent container. It holds the as a it holds as a process ID, as a parent process ID for this application container. That is nothing but a pause container. Okay, so now moving ahead, so we'll discuss about, and we have a very good topic called as a sidecar container, init containers, how to create sidecar containers and everything. That time we will have more discussion about how the sidecar containers behaves with the main application containers. So that time I will show you how to create a sidecar containers, as well as we'll discuss more about the pause container too. Okay. So now, but only keep this in mind that pause containers are behaving here as a parent container for this container one application container. So its process ID is important here. So to start the container, that is important stuff. Okay, so let's move ahead with the another concept of today's important concept called as a volume. So what are the different types of the volumes are there? And we'll discuss about in detail about these volumes as well. We have seen this concept in the containers. Almost same concept has carried forward, but what is there in the persistent storage? We'll see that. So there are different types of the volumes. One of them is empty directory. So what is an empty directory? Empty directory as nothing but it is a volume which is uh, which gets created in the pod. Okay, and the life cycle of this empty directory volume is equal to the life cycle of the container or pod. The moment that container dies, that means pod will die. That means your empty directory will also, whatever the data inside that empty directory is there, it will also get deleted. So for the permanent, for the temporary purpose, if you want to mount with empty directory, if you want to mount a temporary, then we have to use a empty directory kind of stuff. So another type of the volume is host path. So what is a host path? It is something called as a directory or file system which is available on the node. If you want to use that, you can use
And what is the
host.
doctor saying diagnosis? So you start the con. So, I don't like that. Forget the fight.
Please mute. Okay, please mute yourself. Okay, so let me explain you what is a host path and what is an empty directory by drawing the exam, by drawing this in the piece of paper or on the whiteboard. And there is another type of the volume type is also, that is NFS and config and secret. And then there is a persistent volume. So let me explain you with this example. What is the empty directory? So consider that uh, okay guys, I'm just deleting this entire stuff. Okay, so consider that we have a cluster, and inside that cluster you have worker node, and this is one of my worker node. I'm just showing it with the help of worker node. So on the worker node, you have deployed one pod. So this is your pod, right? And inside that pod there is a container, right, guys? So your container, this is your container. Okay, now whenever you want to let's say that you want to use some volume inside that in the container. So consider one scenario that guys, there are temporary files are getting created. Okay, a lot of temporary files are getting created and you want some partition to be mounted inside that, and you want to capture that particular temporary files which are getting created due because of the application. Okay, and but you don't want that temporary files once your application is stopped or if it is crashed or something like that, right? So during that time, you can create a empty directory kind of for loop, and you can map that inside the container. So, so if and now what is from where this empty directory comes? So empty directory comes from volume comes from either from the RAM space or you can use from the disk space also, right? So it can use the containers namespace at the or pods namespace at the host level. It can create one directory inside that, or it can create a directory inside the RAM, and then it will map to the container. You can map that to the container. So whenever there is any temporary files get created, that temporary files can get stored into the volatile kind of volume directory, and once the container is died or pod is died, this will also get deleted from it. That is the use case for this particular stuff. Another thing is that maybe most of the time you require caching kind of stuff, right? Frequently some of the applications are there, or some of the sites you are accessing, or some of the connections you are getting established with another application or maybe outside the application, and you want to cache them, so you can create empty directory. Third important example I would like to give, that there are certain logs which get generated, and that logs you don't want to store, that time also you can use the empty directory. So there are a lot of things we can use with the help of empty directory. So how to create the empty directory, how to mount that empty directory volume, and how to mount that example we'll try to show. This is one type of the store. storage or volume. Another type you can say that there is called as a host path. So what is the meaning of host path, guys? So as it name suggests, host path is the thing, it is a path on the worker node. So consider this is your worker node, and there is one host called as, let's say there is a host path. Host path is nothing but one directory, guys. After all the volumes are directories, guys. It can come from cloud, it can come from your storage, it can come from your local disk. All of them are the folders. So let's say there is a directory called as slash data, right? And if you have this slash data directory and you want to map this directory, this is called as a directory which is on the host. So this is a host path directory. If you want to mount this inside the container, right, then you have to mount this as a host path. So this is specific to the worker nodes, guys. This is not basically used in the production. The reason is that if I create the one directory on the worker node 1, okay, this is worker node 1, and it is created on the worker node slash data. So how it, and let's say this is my pod P1, and there is one application running, and you have scaled up this application, and that application is now scaled to the another node as well. So this is your worker 2. Okay, and this similar container or pod gets created, and now you have, this is a replica of the same pod now, but I don't have the directory here. So will this pod come up? No, this pod will not come up. This will go into the pending state, or this will go into the crash pod. It will not be useful, guys. So whenever you have a single node cluster, like when you are trying to do the testing with the help of Minikube or something like that, you use a host path. But when you have a multi-node cluster, host path is not advisable. Okay, otherwise what you need to do, you have to create a slash data directory here as well, and then you have to copy the data from this folder to this folder continuously. So that is not advisable in the production environment, and that is nothing but a host path. Mapping your host directory inside the container while launching the pod is nothing but a host path. So guys, you have seen that empty directory is used for the life cycle of the container or pod. This host path is used for just for the work one cluster node or for the testing purpose. Then what kind of the volumes we can use? So what kind of volumes or type of the volume we'll use, which will get spread across the cluster, right? So then that comes in mind that you can have one more type of the volume that is called as the NFS type. This is one of the type of the volume you can say. This is my storage box. Okay, consider this is my storage box, guys, and let me draw it properly. Okay, now this is my storage box. It is coming from one of the very nice storage organization. Let's say I have a storage which is of, let's say, 10 GB. One of the partition has been created from the storage box, and that has to be now mapped to this cluster. How do we do that? So, and that should get across the cluster. That is necessary, right? Otherwise, creating a just one directory is not going to help us. So how do we do that? So for that purpose, you can use NFS kind of stuff. You can map this particular folder to, or this particular storage to, let's say one worker node, or you can map it on the master node also. You can map in any of the node, guys, here. Let's say that you have mapped to the master node rather than mapping to the worker nodes. Let's map it to the master node. Nothing wrong in mapping to the worker node also, guys. You can map anywhere. Okay, so let's say that you have mapped to the master node here. Okay, so how to map that, I think everybody knows about that. Is the storage administrator will come, and storage administrator will make this particular storage partition visible on one of the node. Okay, so now you have to format this by using some command mkfs. You have to apply the file system to that, or you can have the file system from the storage itself, and then you have to mount that particular the storage 10 GB storage on this server. Let's say master server. And now let's say that I have mounted this on slash data folder, so that whenever I write some data inside this slash data folder, whenever I write anything, my index.html or my server configuration or whatever it may be, or my application data, my database, anything I can write here inside this one. Actually, this is not writing on this one, it is writing on the external storage. Okay. Now problem is that now it is the same thing like host path, but what is the solution for that? We are discussing about the solution, right? So what we can do, we can use NFS solution. NFS stands for network file system. So you need to install the NFS server. You have to make this master server as an NFS server. So you will deploy the application of NFS server on this machine, right? And once you deploy this NFS server, and you can make this server as a client, NFS client servers, and you can export this to the all the master nodes, and you can mount this as a slash data folder here. So you will have a slash data as well here, as well as slash data here. So this is only possible if you are using NFS, right? Network file system, guys. It is a protocol which is used to share the folder with multiple machines, multiple client systems. So now the data, if the master nodes write some data here, if the user from the master node, somebody access it and writes the data here, it will get reflected here as well. If somebody writes the data here, it will get reflected here as well. So it is the same thing gets reflected everywhere. But actual data is deciding on the storage. This is actually production scenario, guys, in case you want to use any partition from the storage and use in the Kubernetes cluster. Okay. And there are other alternatives that are also there. If you have installed this particular Kubernetes cluster on cloud, so you can use cloud native storages, such as if you are having, let's say, if you have deployed on the Azure, right? So you can use Azure file and Azure blob storage or something like that, and you can map that to the Kubernetes cluster. If you have a AWS, let me draw it properly, guys, so that you will understand. Let's say that you have a AWS here, or you may have GCP, or you may have any other cloud service providers, right? So you can map, you can create a storage here, you can create a partition on this particular storage of AWS or Azure or GCP cloud or IBM or any other cloud service provider. And that you can, these are the providers, right? These are the providers of the storage. Okay, guys, so these are the providers of the storage. So whenever you are using external storage from the cloud service provider, and which are dynamic in nature, we can, let's say that if I have created a 10 GB partition from the Azure, 20 GB partition from the, let's say, AWS, and let's say 50 GB partition from the Google Cloud, and I have mapped to this cluster. So they are the providers, right? They are the dynamic providers. So tomorrow, if I want to increase the size of the storage here, increase the size of the storage here, increase the size of the storage, we can easily increase it, right? So they provide you the dynamic storage. Okay, so you can provision the partition or storage space from the different cloud service provider dynamically as well. Whenever you want to use external storages such as Azure, AWS, and GCP or any other things, there are plenty of the service providers are there into the Kubernetes cluster, then you have to use storage class. So for the dynamic provisioning, you have to use a storage class. This is important to understand, guys. And whenever you are using your local disk or maybe disk from the storage which is inside mapping to the cluster, that type of the storage class is a manual storage class. But when you are using a storage class from outside which is a dynamic in nature, that is nothing but a that storage classes are like Azure storage class or AWS. There is a string. If you want to use Azure storage class, there is a specific string you have to use. If you want to use AWS, there is a specific class that you have to use, string you have to use. Similarly for the GCP. I will be showing you these guys. So do not get confused with the storage classes and the manual storage classes. Okay. So manual stuff is nothing but using a kind of local storage or some storage boxes here, which are inside your premises, in your on-premises structure, and you are mapping that to the Kubernetes cluster. That time you don't have to use the dynamic provision storage classes that time, right? Which is Azure or AWS. It doesn't mean you can't use this local storage as a dynamically. You can provision them dynamically also. Please keep this in mind. Okay. Now, so I was discussing about the empty directory. I hope that is clear. Second point I have explained you that is what called as a host path. Host path is not used for the production. Please keep this in mind. So empty directory. Okay, then another thing is that host path. Third thing I discussed is NFS. Fourth thing I have discussed something about the storage classes. Storage classes, right? Okay. Now let's do this practically, and then I think the things will get clear for you. Empty directory, host path, NFS, config map and secrets I will discuss separately, guys. Okay, you can use config maps and secrets volume as well, right? Okay.
Sorry, did we lose?
I'm back, guys. Just give me 1 second. Just give me 1 second.
Yeah, sure. No problem.
Okay, friends. So I'm back, guys. Sorry. So empty directory is used in the for the particular container or pod. Host path, if you are using it for the if you are using a single node cluster like Minikube, use host path. It should not be used in the multi-node, right? So when you are using it in the multi-node as a multi-node, then you have to use as a NFS, right? And then this is another thing that I'm going to show you, NFS, and then config map and secrets will be discussed separately, guys. You can use this as a volume. And another thing that we are going to discuss today is a persistent storage. So before that, before discussing about the persistent storage, what is the persistent volume and what is the persistent claim, I would like to show you how to deploy the MTDIR and how to deploy the host path and what will happen if you deploy that. All right, guys. So let's discuss about that now. Let's go to the our dashboard command line and let's start deploying it. So first of all, I need to deploy the pod, right, guys? So let me see kubectl get pods. Yeah, we have a couple of pods here. Okay, and let me see kubectl get deployments. Yeah, so there are. So let me create a pod, new pod now. So let me use nginx pod. Okay, guys, pod1.yaml, and let's write it quickly. API server, API version. Anyway, no need to no need to write it again and again that because it will take a lot of time, guys. So let me copy it from some of the pod file. Yes, vi pod. So let me copy this. CPS dynamic. This is for the dynamic provision that we are going to discuss. And let's say pod1.yaml vi pod1.yaml. Okay, guys. So I am deploying the pod kind called as a pod. Version is v1. Metadata is my pod. All right. So we are using a container called as name. Container is my pod and its image is 1.15. I can use directly only. Okay, let it be like that. And let me remove these resources right now. We don't need it. Okay, so these are the two things that you need to keep in mind. You have to declare the volume and then you have to declare the volume mounts. So volume is the property of container. Okay, sorry, property of the pod. Volumes comes with the property of the pod and the volume mounts is the property of the container. So I need to declare here whatever the volume I'm declaring here. Let's say that I want to declare as a volume. Let me delete this. And what kind of volume you want to map, guys? It is empty directory, right? Okay, so now where you want to mount? Let's say that I want to mount inside the container on the path called as, let's say slash data, something like that. Okay, and which name you are using? You are using this article called as a volume. Okay, guys, so this is very simple, right? So we have to declare volumes. So later on you will use declare some other volume also, and whatever the volume you are creating, you want to mount that somewhere. You have to use under the volume mounts. You have to give the mount path and the name of that volume which you are using. Right, guys, and let me now try to deploy this and see what happens. So if you want to see the correct, if this definition is correct or not, let me go to the kubernetes.io, Kubernetes volumes mtdir example. Okay, now you can go here. And if you want to specifically use for the empty directory, you can go here, emtdir, and now see here how it has been used. Right, so you can see here it is mtdir, and okay, so there is a mistake I have done, right, guys? So you have to use capital D. So this can happen in the examination if you have to use, right? And let me delete this. Okay, and let me use here curly brackets. That's it, guys. And this will get mounted on the mount path called as a slash data. So mount path is my slash, whatever the data you want to use, you can use that, guys, here. Okay, now let me save this. And apply this kubectl apply -f pod1.yaml, and it shows that pod is created. Kubectl get pods -o wide, and it shows that create container is creating on the worker 2. Hope that it will get created. It has created, and now it is running on the worker 2. So now I will log in inside the container by using kubectl. Or first of all, let's describe this. Describe pod my pod, and there will be some volume type. You can see there this has been used as a type as a directory. Can you see here mtdir? And you can see the mount here is your slash data from volume, which is in the read write mode. Right now, if I go inside the container kubectl execute -it, and I need to use the pod name, right? So what is my pod name? The pod name is my pod, and give the bash. So I'm inside the bash, and you can see here, go to the data folder, right? It got created automatically. Now I can use this touch one dot. I can create hundreds of files here, guys, right? Let me use create only one file, one.txt, by using one command. It got created, right? So moment I delete this one, the empty directory will go away, right, guys? So let me exit from this place, right? And if I delete this kubectl get pods, and if I delete this particular pod, the slash data directory or empty directory which you have mapped will also get deleted. So sometimes this particular empty directory gets created inside the RAM. It use the space from the RAM, or it use the space from the kernel level. So I need to check whether by going inside the worker 2, whether it has used the space from the container level or in the RAM level, or it is using the space from the host level of the worker now. Okay, so this is something called as, guys, assigning a mtdir. This is the normal way. You declare this volume and you map it. Now, next thing that we want to discuss is that, let's say that I have a directory called as mkdir slash data on my machine. I have some data created here. And if let's say that there is some data called as 1 to 10.txt. Now I want to map this particular directory inside the container. So how do I do that? Let me copy this pod1.yaml, pod1. Oh, it is in the Kubernetes folder, guys. cd slash root slash Kubernetes cp pod1 pod2.yaml. Okay, vi pod2.yaml. Okay, so now I want to use something called as another volume. Let me use the name of the volume as my volume, and host path is equal to slash data. And you want to map this particular slash data on the mount path on the inside the container on the slash data one. But what is the name of the volume? You can use my volume. An important thing, guys, you can specify the size for each mount point, as well as you can specify the size for empty directory also. Okay, you can do that. All right. So now this is done. So let
Will be a capital P in host path.
thank you. And now let me go to the this is my pod one, so it will not get conflicted. Container name also I'm using a my pod one, and we are going to use the same image. Otherwise, what I will do, I will use a mounting path as user share little bit because I don't want to anyway, data one is okay. Now let's save this. This is important, guys. Name should be same. This is very important. Which volume you want to map, that is called as a my volume. Which host, what is the significance or the property of that is slash data mounted on slash data one. So let me save this. Kubectl apply -f pod2.yaml. It shows that something is wrong, right? I have used the wrong thing here. What is it? Host path invalid type. Okay, so let me see what is the mistake I have done. I have to go to the volume. There will be some host path kind of thing, example. And here example is given. Oh, so I have to use a type called as host path here. Inside that, path is equal to data and type is equal to directory if you are specifying. So let me use this, guys. So this is the way we can cross verify if something goes wrong with our deployment vi pod2 dot. So I need to use here name is okay, host path. So I need to use a host path as path. And what type of the path is this? You can use a directory. So I can use a type here. The property of this is a type. This is my directory. Correct. I think that is now perfect. So if you want to declare a host path, you have to declare like this one. Host path is, and you have to give the array information in the form of the array. So let me, no, it is not array, it is a key value. Let me save this. And now let me deploy it. Kubectl apply -m. And I think it should get created. Now, what is the problem, guys? See, now I have created, will this pod come up? It is showing that pod is getting created on worker 2. Let's watch it for a couple of seconds. It is still creating a container. Guys, if you see the diagram here, in the diagram, I have created a slash data directory on this particular master server. I have mapped that inside the container, right? But that container has got deployed on this master worker 2. Over there, this slash data folder is not present. What will happen? See, it is still creating a container because it is not getting a volume. It is not getting this directory slash data on this one, right? And that's why if you are using a host path type of the volume type, you have to use in the single host, right? Now let's see if I want to show you the description about this. Will it give us a description? Kubectl describe pod my pod. Since this pod is not in the running state or completed state, will I get anything, right? But if I get something, now see it is showing failed for volume my volume host path type check failed slash data directory is not a directory. Slash data is not a directory. So that's why it is failed. It is showing you the host path is slash data, but it is not getting this information, and that's why it is failed. So that's why this kind of, if you are using a host path, you have to use it for the same machine. Now this will get appropriately worked if I create a slash data folder on the worker 2, because then it will use the host path called as slash data from that worker 2. So I need to create a directory here, then only it will work. But that is not a good case for the production. And hence, host path should not be used in the production. So instead of that, if you want to share such kind of folder or directory which is coming from the external storage or from the internal storage, what you should do the NFS mapping. So how do we do this NFS mapping? That we'll see, guys. So before moving to the NFS mapping, I think I have taken the two small topics called as MTDIR and the host path. If you have any specific question, let me go through the chat box first of all, and then if you have any questions, then you can ask me, guys. So before that, please don't. Okay, let me just. Okay, Abu, that question I think we will take it later on. And see the spelling mistake you are doing. It is export kubeconfig slash admin dot conf. F is missing there.
Yeah,
Probably that would be the reason.
yeah, I got it. Yeah, the F was missing. Thank you.
Yeah, okay,
Thank you.
okay. I hope that Vivek you got it. Okay. Do we need to set up this or it's set up does automatically? Which one? Sudhakar, I think you got the answer up, right? Yeah. Can't we have a shared mount point and which can be used by? Yeah, that is we are going to see Sumanta now. Is the default pod container that manage PID? Does it initialize the PID for all containers in the pod? Yes, yes, Anand, that is correct. It manages the PID for all the pods. So if you have multi containers in one pod, there will be only one pause container, not that many pause containers. We'll have only one pause container. Okay. Yeah, so we will do the NFS now, Ramesh Prajapati. Abhiram is saying if I have logging stack driver etc, then empty directory may not be required. What is the logging stack driver? Yeah, right. So the question comes that Abhiram, if I have a logging stack driver etc,
Yeah,
then
stack driver you told, right? I mean, empty directory for logging. That's what I was wondering. Like, if you have some kind of logging framework, will not require a empty directory, right? Or
in the no, this empty directory I have given the example for logs which are not required after the container dies. That in that case you can use the empty directory as a log directory. Otherwise, then it is not required.
but normally we can use stack driver for anything, right? Whether container dies or not, right? I mean, then
Do you want to keep the logs again? Yes, that time, yes, of course, you can use for that purpose. Both purpose you can use it.
okay.
So, Ramesh Prajapati, your question was related to NFS, right? So we will do that one right now
Yeah, Ramesh,
because
yes.
so what we are going to do, we are going to create a mount point on the master node, and then we are going to export that to the clients. Yes, you can use the Azure Disk Amiram as a storage class, and you can map that.
Okay.
Yeah. Is that NFS storage volume considered the production ready environment because NFS version 4 doesn't provide high IOPS encryption etc? So if you don't want to use NFS, you can use dynamic storage classes. You can. So there are certain other protocols are also there, like CIFS and others, that also you can use, which are in the advanced version. Partha Sarthi, is that okay?
Yeah, got it. Thank you. Thank you, Ramesh.
Yeah.
So, Ramesh, in the same context, like when do we use storage versus dynamic? So is there a difference there because you're telling both are same, right?
No, I'm saying that if you are using um, external storage drivers such as Azure or something like that, so and if you have deployed the your Kubernetes cluster inside the on the Azure or AWS, that time it can automatically, if you want more size, or if you want to claim more size on the volume, then you can do it dynamically. Okay,
Okay.
but right, but if you have deployed the cluster on your on-premises server, then how you are going to, because that dynamic provision is different, which you are using in the cloud. That cloud service provider take care of it, right? They have an integration. But if you want to integrate the cloud service providers EBS volume or any other volume, or your storage which is coming from the, let's say, NetApp storage box or something like that, and if you attach that to the cluster, that also can be used right there as a storage. But there also you can define that as a storage class. You need to define the storage class driver other than the manual storage driver. So then it will become a dynamic provision.
Okay.
Okay. So I think we will discuss about the storage class in the dynamic provisioning very nicely. I think that time it will be crystal clear for you. Venkatesh, if we use a host path in multi-node environment, right, then it is a complete manual stuff, you said, right? You have seen that now my pod is not coming up in the
Yeah,
another
yeah.
node.
Yes, Ramesh. Yeah, generally we use NFS, right, in production and non-production in a multi-node environments, so that
Right.
we share the binaries or whatever it is. So that will be useful that way. Yeah, I understood that.
Yeah. Right, Venkatesh, correct. Okay, Abhiram. Production will have multi-node environment. There should be other reasons. Okay, I hope that Abhiram, that discussion is now properly closed, right?
Yeah, yeah.
Surinder, I will be taking that one later on when I discuss about the ingress controller. That time I will take it. Blue, green, and canary deployment strategy topics, right? That will be deployed. Don't worry about it. Okay. I think it is already answered. Thank you. Yes, Venkatesh. Prod and non-prod environment are nowadays using NFS mounts. Even the IO is much faster. Okay. We need to check whether NFS 4 is better than the NFS 3. I think NFS 4 is better, but you have just called you are saying that input output operations are, but IO ops are really dependent on the hard disk speed, not on the, I think, NFS TPS. It is not a NFS TPS. It is a TPS of the or IO ops of the hard drive, right?
Okay.
Venkatesh. Yeah. Do you have a difference between host path and others? So difference between host path and empty directory I have shown you. We are going to deploy now NFS, right? We are going to do the persistent volume and persistent volume claim, I think. So I hope that you got the difference between host path, empty directory now, and as well as NFS.
Yeah.
Okay. Okay. How do I decide premium versus standard versus inferior with real-time example, right, Abhiram? So inferior is nothing but it is just temporary, right? It is during the time of the pod or container. If you want to use, you will use the inferior kind of, right, storage. I hope that is clear now. For the caching purpose or some temporary files, if you want to store when your pod is there, and if you don't need it later on, it should, you will not bother if it is deleted, right? So that time you will use a imperial.
So,
Okay, and what is the
so imperial here? It is like more of a stateless way of doing, right?
no, that is stateless and stateful in this sense. I don't think so. It will be where what is the stateless and what is the stateful now
No,
on
I
the
mean,
imperial?
so in the sense, like, I mean, something to do with stateless here, like means uh, like database based. So those will require premium. Is it something like that, or I mean,
Yeah,
or that?
because premium and standard is nothing but you are talking from the input output operations IOPS. If it is a premium hard disk you are using, if your entire database is coming inside the RAM and the database is really RAM intensive, that time you have to use a premium storage for that purpose, right? Where you want higher side of the caching.
So what
Are
is
you
higher
getting?
IOPS? Like, what is the definition of like? Is it like 500, 100, or I mean, that do we have
Yeah.
like higher?
No, IOPS is nothing but input output operations, right? And the SATA supports only 200 IOPS. And if you have a premium or if you are using SSD, in the SSD also there are multiple types are there. So some of the hard disks which are general provision, the GP2 kind of stuff, they provide up to 5,000. And if you are having a premium kind of hard drives, which give more than 10,000, 11,000 of the IOPS, right?
Oh,
So reading
okay.
and writing speed of the hard drives depends on the type of the disk you are using.
But standard is same as imperial, or like stand, because premium I got it, but standard is same as imperial, or no? I mean,
If you
is
are
there?
discussing from the, if you are discussing based on the IOPS standards, then Imperial is just, you can say it is kind of a little bit faster. You can always say that because it is using a RAM, right?
Okay.
And if you are using extending the storage, or if you are using the your RAM as a hard drive as your kind of extended RAM with the help of swap or something other ways, that time you can say the premium or standards will come into picture.
Okay. So when it comes
And
to IOPS, the highest is premium. Second is what? Like when it comes to
standard,
IOPS, like what? Standard, and then lowest is the imperial. Okay, that's what I want.
no, not that way, not that way at all.
Okay.
Imperial is nothing but if you are using a RAM, if you are using
Mm.
a RAM as imperial storage, and mostly that is the case, empty dir or something like that, or if you are using external storage as a, let's say, inferior storage. So if you are using a RAM, it has a higher speed. Okay, it has a higher speed. It has a highest IOPS,
Okay.
right? Because it has internal and it has a direct CPU and IOPS connection. I will not go into that discussion, but it has a highest IOPS. Standard is nothing something like that. You are using a magnetic kind of storage device, where example of that is a SATA hard drive, which
Okay.
has a hardly 200 or 300 of IOPS. But premium is nothing but nowadays it is a SSDs, which are coming with a different speed horizons, right? And that has a good speed. That has a, when I say good speed, that means it has a good IOPS.
Got it. Okay.
Yeah. Okay.
Got
So
it.
in this case, yeah, thank you. In this case, it is using the slash data. Can we configure the pod to use RAM for the MTDIR? So basically, where this slash data has got created. So slash data has got created inside the container. MTDIR, we are not sure with, mostly it takes from the RAM only. Are you getting it, Sumanta?
So
Okay, so
is there a way we can explicitly define that for MTDR, whether to take it from RAM or hard disk?
you can explicitly define. So whenever you are using any other storage device as a MTDIR, then you can use it explicitly. Yes, we can use it. There
All
was
right.
one question. There was one question like, can I use Azure Disk or can I use EBS block as MTDIR?
Right.
Are you getting it? Yeah. So that can be used, right? But that has to be defined in certain ways. I'll just try to fetch out the way it has been defined. How do we
But
specify
yeah,
that? Hmm.
but in that case, how would we know that the provider, whether provider has given us the RAM or it's on the hard disk, or that's again configurable?
If you are using, if you are not specifying any provider name,
Hmm.
okay, that time it will take from the RAM.
Okay. So then it cannot be configured if there's no provider. Let's say it's all on premises, and you just basically the moment you say empty-dir, it'll take it from RAM, right? In that case, there's no way we can manually or explicitly say that, okay, don't take it from RAM and take it from this hard disk.
Explicitly, that in the earlier statement, I said that if you want to explicitly
Hello.
use the any other devices or any other storage to map inside the as an MTDI, you can explicitly define that that provision is there. Okay.
Okay.
But if you are not using it explicitly, then it will
Okay.
take it
Then
from the RAM.
RAM. Okay. Cool. Thanks.
So Ramesh, in our case, we are using volume, right? The local directory, right?
Yeah, we are using local directory. Yeah, we are using
But
this slash data is not a local directory, Sumanta. This slash data is inside, it gets created inside the pod. So if you see the definition again, vi pod1.yaml. Look at this. This is a mount path. This mount path will get created inside the container.
so there is
I'm
no specific physical location
no
for this.
right.
Okay.
Yeah.
Because
So
you
the
said
point of
we can define it
yeah,
in two ways, right? In RAM and physically, right? So
right.
this one we have created, I mean, in this configuration, it has been created in RAM, right?
Yes. Yes. Correct.
And we can't
I
see what is there inside it.
I have to open the RAM for that.
Okay. But then have we seen in this case that, physically, if I have to use a physical path, then how it is going to be?
Yeah, that is what I said, that I need to extract, I need to fetch that, how to get that empty directory mapped with the inside the as a empty directory, how we can external path can be mapped to it. That I need to fetch the information. I'll check that and I'll come back.
Okay. Thank you.
Normally in the training concept, we just only go with the kind of stuff and then we go ahead, right? But actually in the production, if you, and in the production also, if you want to use your MTDR as a flash disk, where a lot of transactions are happening in the RAM itself, so that time your MTDR will be useful for you. So that flash disk can come from the outside, not from the inside.
Got it, Ramesh. But then in the host path scenario, which you have given a demo, in that
Right.
case, are we using a physical location?
Yeah, we are using a physical location.
Physical
Yes.
location.
Yeah, we are using physical location. So if you see here
Okay.
pod2.yaml,
Right.
yeah, this is the directory. I have
This is a directory. Okay.
created this directory on the my host.
And you said that volumes are for pod and volume mount is for container, right?
Volume is the property of the pod.
Yeah.
Like container is a property of the pod. Similarly,
Right.
volume is the property of the pod. But where you want to mount, that is a volume mounts. It is a property of the container.
So in this case, we have slash data, okay, whereas we don't have slash data one, which is virtual, right? Slash data one.
Slash data one is inside the container. It will get created inside the container automatically.
Container, but then you can't see it, right?
So we can see it. We can see that.
I mean,
This we can.
inside, if I go inside slash data, can I see slash data one or what?
No, when I go inside the container of my pod one, when
Right.
I log in inside that, I will be able to navigate to the slash data one, and I can see all the information over there, which is present inside the slash data.
Okay, got it. Thank you.
These two are same.
Yeah, these two are same. Okay, thank you.
Right.
So Ramesh, for host path type, right? it is directory, and I see another way, parameter there. It says directory or create. So when we use that one, what happens? It creates the directory, or
Yeah, if you don't have the slash data directory created, and if
okay.
you want your manifest, this manifest should create it automatically, then you can use create directory.
So in that case, on which node the pod is hosted, the directory will automatically be created on that node.
Yes. Yes.
Okay. So if the pod is, if the node is down and if the pod is moved on to a different node, and the directory is automatically created again on the other node, right?
Let's do this example before. Okay, let me just take the example. This is a very good example. Okay.
Ramesh, sorry.
Mhm.
Can you just go back to your screen that on a
One
terminal?
second. Just 1 second. I'll come back. I'll just come back. Host path, right? Where it has gone.
Up there, that's the host path.
Yeah. No, but I need to check it's
The one below that one. Yep.
you know, I can see here this is only type
The
directory.
one below, there is another one below. Yep, here.
Yeah, right. So this is a directory create. This is the thing that you want to show, right? Let me do it, guys. Yeah, and I will take your question also. Just 1 second. Okay, and let me use this as a data 2. This can be 1, that's no problem. Let me use this as a data 2. And my pod 2 is, name is my pod 2. Container name is my pod 2. I will come back to your question. Now you wanted to ask some question from this one. Somebody said that go to the screen back. So I can take that question and then we'll go create this one.
Yeah, you continue. Maybe like it might be answered with this one. If not, then I will ask once again.
Okay, no problem. Thank you. Let me
Ramesh,
save this.
why you changed the pod 2? The pod was not created last time.
No, it was there. It was in the pending state. It might be in the pending state. It was created. It was created. You can see it is in pending state. It was a pod 1, but kubectl create -f pod.yaml. Okay, and where it is going, kubectl get pods -o wide. Yeah, it started working on the worker 2. It is running. Still my pod 1 is not, it is in the container creating state because it is failed. And if I log in here in my pod 2, kubectl execute, right? -it my pod 2 / bash and /data2 if I'm not wrong, right? Is it map /data? I'm sorry. So I can use ls command to see. It is data1. See here. So inside the container, data1 has been created. Okay, no data is there. But has it created the directory inside the worker2 called as /data2, right? So let's check out that. So cat pod2.yaml. It is a data directory, right? Let me go in the my worker2 and let me check out quickly. I need to get the IP address of it.
Ramesh, can you explain the concept? What are we doing here, just to high level on this example?
What we are doing, we are specifying in the host path that create a directory if it is not present in the node.
Oh, and I understand, but okay, let's complete the exercise. Then I need to understand this. This is really good, and I need to understand from the basic point. Are we creating a host path in worker one, right? And then we are then that pod is created in worker two, but it is still have the map to the worker one, the data one directory. That's what we are doing.
No, 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 no. It's fantastic. Let me explain you. Okay. It has got created automatically. Okay, on worker two. Look at this. I
Whiteboard
didn't.
it, you can explain it later.
Yes, yes, I will explain. So, guys, it has been successfully created. Let me explain you this now. Thanks for
Ramesh,
asking that.
Ramesh, when you write, we can't see that. Can you bring your screen a little bit up so that when you from the bottom it is getting cut? Yeah.
No, that's fine now. I think it is up to this point. Can you see this?
Yeah, yeah, we can. Yeah.
So, guys, you see the YAML file of the worker one, pod 2. Inside that, what I have written, look at this. This is a volume I have created called as a host path. And the name of the directory we have used as a /data2. And what we are mentioning here is that if that data2 directory is not present on the specific worker node, use command called as a directory or create. If it is there, then fine. If it is not there, then create it. And because of this, it didn't fail. So now this /data2 directory, I didn't create it manually on the worker 2. It got created automatically because of this keyword.
It will create mkd. It will run a command called mkdir to create if the directory is not there.
Yes, yes, right. It will.
So this data2 is directly mounted using the space of data1.
No, it is right now. It is mounted on the data1. So /data1 is, it is not mounted. It is mapped.
Mapped. Yeah. So if you create multiple containers, okay, in the same pod, okay, then it will be using multiple, like /data1 or /data2, whatever it is, and all will be mapped to the same parent directory, which is data2.
If you want to map, you can do that. Yes.
Okay. Thank you.
So that mapping depends on the name, right? So let's say we have one container with name volume mount name my volume. Let's say I create another container with new volume name my volume 1, and we can and also we need to in volumes also we need to create another section called my volume 1, right?
Yeah, no. If you want to use the same volume to be mapped with the multiple containers, use the same name.
Okay.
But if you
But if
want,
you want to do multiple volumes, we need to give multiple names and map those.
Yes, correct. And you can map multiple volumes in one container also.
Ramesh, continue to show us the file you create if it exists in the container, please.
Yes.
So Ramesh, this one that you're creating in the master, it will be done in the worker node, executed in the worker node. Is that what we are doing right now?
No, let me explain this.
So, sorry, my bad.
Yeah, no problem.
Yes,
Hisham, this is
yes, Ramesh, I see. Because sometimes there is interruption to each question. Bring each question. We don't continue the flow, all the flow. We continue flow, and after, if there is another question,
that I understand that. I understand. I can understand that. Okay, guys. So let me explain you what I did now. Okay, those who let me so that everybody will be comfortable with this. Okay, so what should I use now? Let me use this eraser first of all. Let me remove all the stuffs. Okay, and now see here, guys. What I did, I have written one YAML file, and there I have written in the YAML file that look, where is that YAML file? Look at this one. My volume type is host path, and I am using the path called as a /data2. Map this volume to the /data1. Right now, as per this scenario, we don't know where this particular volume is getting created. or we don't know where this pod is getting created. Is it on the worker 1 or is it on the worker 2? So how you can make sure that this but that the directory should be present, right? That directory should be present in that worker node if this pod should come properly. So there is one type is given here, directory or create. So if the data2 directory is already present, then it will not create it. But if the data2 directory is not present on the worker 1 or worker 2 where this pod is landing right now, it will create the directory. So this will get created on the worker nodes only, because your pod will get created on the worker node. That's why it will create on the worker node itself. Right?
Could you explain in the whiteboard?
Yeah. So guys, what I have explained you here now, I have created a YAML file on this master node. I have given it to the API server. Okay, and there I have written that create a pod on any one of this node depending on the scheduler's call. But when it is creating, then it should create a directory called as a /data2 or data whatever it may be, and mount that directory inside the container 1 as /data1. If this directory is not present, then create it. If the pod is landing,
does that mean it creates on both the workers?
no. It will only create on the worker node on which that pod is landing.
What happens if the pod is deleted later on? The data that is still be available in that worker node?
Yes, it will be available. It will be available. Yes.
And what if the worker node itself is not available?
It will not get created. Pod will not get created on this one. Then it will go on to another one.
No, what I'm saying is, I mean, as both the worker nodes are in a cluster, okay, and initially the pod got created in worker node 2, okay, where it checked whether the data2 directories exist or not. It doesn't exist. It went ahead and it created the data2 directory. Now now the pod is up and running in worker 2 node, okay. So after some time, the worker 2 node, due to some incident, it crashed. Okay, it is not available. Okay, now the pod, because of this high availability feature,
I got your question.
Okay, thank you.
Okay, so I will show you that. Now for that purpose, I need to create a deployment, right? I will not be able to show with this example, but I will try to create a deployment and show it to you. But before moving to that point, do you have any question on the this particular part, which I have created now?
So /data1 and /data2. Is there any mapping or dependencies as per the YAML?
See, this /data2 is the directory, okay, type of host path, and this is a container /data1. Inside the container, this /data1 will get created. You are going to map this folder, which is creating on the worker node host, to the containers folder, that is /data1. So whatever the data you are writing in the /data2, it will get reflected inside the /data1. Whatever your data you write in the /data1, it will get reflected in the /data2.
Correct.
So it doesn't matter with the folder name. Only the folders that we are mapping, the contents of the folders will be
always same.
Replicated.
Yes, it will remain same.
Irrespective of the folder name.
Yes, correct.
I have a question, Ramesh. I don't know if in this YAML file we decided to have like 3 replicates. So the replica going to be created on different nodes, right? What's going to happen with the path? With the path going to be created, the directory going to be created in each node, or how's going to happen?
Yeah, it will be created on each node, and that I'm going to show you in some time.
Before creating a deployment, Replica said, if I have one question, let's talk about a single pod example. Maybe deployment might be the better fit, which gentleman asked the question. But before that, if we are creating a single pod, and then master is going to, the API is going to create a schedule, the pod in worker 1, let's say, That's fine. Pod 1 is created and pod 1 in a worker 1, and then we create a host path and we got a mapping, everything's done. Good. Now I have another request to create pod 2, and I want to use a worker 1 host path for pod 2, irrespective of if it's, let's assume that the pod 2
You can use
created
it.
in worker 2.
You can use it. You can use it.
No, let me complete my sentence. Now my pod 2 is created in worker 2, but I want to state my definition in YAML that use the host path of worker 1. Don't create a directory or use the whatever on worker 2 host path. Use worker 1 host path for pod 2. Is it possible?
So that means you are saying that no, that is not possible. It will create a
Why I'm asking this question is, let's say your persistent hard code mapping with pod and a host path, which is worker 1. Now you have to have your pod 1 to be created in worker 1 because your host path is on worker 1. That's a hardcore dependency, right? Now I want to remove this dependency. I'm not using NFS share. Yes, I can do that, but here I'm using host path as an example. I have a data available in host path. Now that is something called persistent, right? Because the host path is basically a worker directory. It is not a container directory. So it can be a persistent, right? Somewhere, somehow.
Right.
I have a data available here right now. Now pod 1 is gone. Let's say my pod 1 is gone. I've deleted or removed the pod 1. I have to create a pod 2, but I want to create the pod 2 in worker 1 where my all the data was there in host path. I want to create that pod 2 in a worker 2 node, right? Now I want to use the old data which is still available in my worker 1 host path. Can I correlate that when I'm creating a pod 2?
No. With the help of host path, you can't do that.
This is not a scalable solution. First of all, if you're trying to develop such thing, this is definitely anti-pattern. You basically binding your pods with the nodes, and it can't scale.
But my question is this: that if okay, let me rephrase my question. Is it that host path I understand that directory empty directory is persistent. Like, I mean, it is if in it will go away somewhere. It's in RAM. Once a container dies, your data is gone. What about my host path data? Is it persistent or not persistent?
It is persistent. It will not get deleted.
Persistent for a node. If node is gone, it might be gone because it belongs to a node, not a pod.
Got it. Very good. Now, if your data is available in worker node 1, can't we use that worker node host path for some other worker 2 mapping or something? I mean, we can do a sharing or mount point or something. And
in that case, you need to use the NFS mount, right? That only solution would be using NFS mount than using the host path. So irrespective of 4 or 5 nodes, wherever it is called data is there in an NFS mount or a disk somewhere, you use that. I mean, then using the host path would be anti-pattern rather than this would be right way.
Or you have to manually write this mechanism, which apparently is just what NFR provides you.
Yeah, in that case, the architecture is not good. Only thing we have to check. See, while it is anti-pattern or it could not be, conceptually an invalid use case, but the question still is from Vivek whether the whether you can use from one worker node to another worker node the host path. So is there a feasibility?
No. You cannot use the data from one directory of the worker node as a host path type volume inside the another that we cannot do. I'll tell you one thing, guys. This is not a valid solution or viable solution for the production. That is, first of all, please note down that underline that statement. But second important thing I would like to do now is that when we deploy the pod, let's say that if you do the deployment kind of stuff and one pod gets created here with the host path called as /data here, and this another replica of this pod got created on the worker 2, and it also created a /data. Now inside this C1, the data which is we are going to change or modify, that data will get stored here only. And if you are changing any data here, that will get stored here only. So that is going to create a problem. So that's why this is not a viable solution for the production.
So the sync between the data folders across different nodes will not happen.
Yeah, with the host path. But if at all you want to sync in the different way, like write rsync script or take a backup or replicate from, that is a different story.
In the current scenario with host path, the sync will not happen across data folders on different nodes.
Yes, correct.
Okay.
Okay. So let me see.
No, I was thinking if they just use the master node, because that is no, that's fine. Just never mind. Leave it.
Yeah, right.
Then that will come under NFS then.
Yeah, we'll do that one, guys. We'll do the
No,
NFS.
but it was a good question, Vivek. But yeah, like you are ideally like if you are going for such design, so I think it's not feasible. Yeah, good question, Vivek.
Yeah, very good question. Yeah, thank you.
So that
But
answers my question, right? If node 1 gets down, then you can't use node 2 gets down, then you can't use node 1. Why? Because the data is not synced.
Right. But see, I'll tell you, the data is not synced. But if you are trying to create a deployment, and I am still going to do that one, I will create a deployment and try to show you. And let's see that what happens. But first of all, let me check out the questions now.
But this can be addressed, issue raised by Vivek can be addressed if you mount the storage on both worker 1 and worker 2, the shared storage. Then that issue can get resolved, right?
But at any point of time, if you are mapping the same storage, external storage on the both machines, right? Same machines.
Yeah.
Right. Then that issue will get resolved. But you don't have to create a directory also. You have to mount the directory, but specifically. Let's say this is your external storage. This is a 1 GB to 10 GB storage, and you want to make it visible here as well as visible, and that is possible, right? And if you are doing that one, you have to mount it here as a slash data, then it is same solution. Then you will be having the same solution. Same
That's
data will be there.
That's NFS, right? Ramesh?
No, this could be done under host path only.
This can be done under the host path, but the protocol which will be used by the storage to make it visible on the both nodes will definitely use some NFS or iSCSI protocol.
Okay, yeah.
Do you have, okay, Abhiram, I answered. Is there any question which is left out, guys, now?
So, Ramesh, we can see this way, right? Storage, the NFS is for on-premise, and the storage class with dynamic one is for cloud, right? That way also is the right way of understanding, correct?
Yes, that way, broadly you can define that way. Yeah, just give me some time. I will show you the storage classes also. Just 1 second. Abu is asking, my containers are not running, but somehow. Acha, okay. Abu, is it okay now?
Yeah. No, somehow I don't know. It's just anytime I start, it just keep on the. It's just saying like creating, container created instead of running. It's not running. I'm not sure why. Maybe I'm missing something.
Okay. I think Piyush, can we take the login later on and check out what is actually happening, that you can check it?
Yes, Ramesh. Yes, I can do that.
Yeah. Okay. I think Vivek, we have discussed this, right? Yeah. It shows error message and all. Please create directory worker. Yeah, okay, that's fine. I think we have discussed a lot after that. NFS mode does not have storage class. Okay. Aviram, this is a question you are asking, right? NFS Mountain does not have storage class as cloud providers, right?
Yeah.
Okay. We'll just discuss about this in the storage class. When I open that storage class sheet, I will show you that one. Can we use can we use multiple storage for a single container? And if so, yeah, I think Pujita, we have discussed, right? Any specific question do you have? We can create multiple storage and we can mount it. We can mount the multiple volumes inside one container as well as multiple containers. I hope that that is clear now. Yeah, Praveen, that is true. Thank you for bringing that one. Where is data? I think, Vivek, I think we have discussed, right? This all stuff. Sonal, is it clear?
Yes, Ramesh, thank you so much.
Anirban is asking, is the directory created on the host path is one worker node controllable from master node? No, 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 that is not controllable. Anirban, that is not controllable. It is a host level, operating system level that directory is created. So then you have to use the Linux concepts altogether, different concept to manage it.
Yeah.
But
Yeah,
through
got it.
Kubernetes, we cannot do it. Yeah. Is there anything like shared volumes? Okay. Yeah, that is possible, Sonali. Okay, thank you guys. I have answered all questions. Let me try to create a deployment and show it to you guys how it will behave if you create a deployment. Will it create the multiple directories on that one? And what happens if we delete the pod right now? What will happen to the directory which is there inside the, is it 9 o'clock? Oh no, Abiram, just give me a couple of minutes to finish. Let me finish this one and then we'll go it. Just 5 more minutes. Let me go to the worker one, kubectl get pods. Okay, so let me delete this, guys. How I should delete it? Yeah, this is the pod 2 I have used. So let me delete it. To confirm you that even if the pod gets deleted, data deleted doesn't get deleted. So you still have this slash data 2 on the worker 2 and still have a data inside it. So host part
That is
directory
what my
doesn't.
question was. Sorry to interrupt you again, but the data2 directory, the file which we do have 1.txt, I want to preserve this. I want to create another pod 3, and I want to use this data, which is, let's say my new pod is created in worker 1, right? Now the data 2 is created in worker 2 as a directory host path, and then I want to use this data for pod 3, which is created in worker 1.
Right. That is possible only if you now map or export this slash data to folder on the worker one as an NFS.
Okay, so NFS, that's what that's a Linux, I mean, lower level, not on the Kubernetes level, but the Linux level, we can do that.
Yeah, no, the Kubernetes understand the NFS.
Okay.
We are going to, that is what our next, after the break, we are going to do that one. Persistent volume. Okay, guys, cool. And let me check quickly, guys. CP. It will not take much time, guys, don't worry. To pod 3, I'm creating deployment with host path .yaml.
This is a typo. No, it's fine. Just
Okay.
file name. Just a file name, yeah.
This file. Okay, and now what I need to bring that data here, right? So is it appropriate? No, I think not, right? This is the property of the container, right? And this is your pod property. It should be in sync with template, replicas, and selector. I think it is perfect. And let me use the host path as data3, which is not available, and we'll mount it on the /data1. But here we'll create a 5 replicas. So one of them will go to the worker 1 and one of them will go to the worker 2. Okay, I think it is perfect. Let me save this. kubectl create -f deployment.
That volume should be in path. It is a property of pod, right? So it should be inside template. You made it in line of template.
Right. I have made it other with the deployment, right? That is the wrong thing.
Yeah, right.
It should be with the template or specification.
Spec, yeah.
Yeah.
Now looks good.
Yeah, it looks good now, right? Is it okay, guys? Yeah, let's see. Unknown field mount path. Okay, I think it should be in sync with the containers. Because container is the property of the pod and volume mount is a property of the container. So
mount path also is not aligned properly. Yeah.
Should go with spec only, I guess. Oh, anyways, we'll try.
Space is a property of the this one only. Right, and deployment. I think now this is fine. Yeah, let's see. Now it is created. kubectl get pods -o wide. It is getting created. Yeah, it is started. Look at this. It is working. So if you go to the worker 1 or worker 2, now data3 folder might have created. Yeah, it is created. Nothing is there inside it, but it is created now. Data3. So same thing is in the worker 2 also. So it gets created, guys. Okay.
So Ramesh, let's say, does it not create any data consistency issue because the data is actually being shared among multiple containers and pods, right?
It is completely inconsistent. It is completely inconsistent.
Yeah. Okay.
Sorry, but can you explain again one more time?
Yeah, we have to use NFS for the consistency.
Hey, Ramesh, can you explain the whiteboard what we just did with using deployment? I just missed the part actually.
No, what we did here actually, we have defined the host path as a data3 /data3 and asked YAML. We have written in the YAML file that create it on all the worker nodes. If it is not present, then create it. So what happened when you deployed it? It has created directory on the worker node also, as well as worker 1 also and worker 2 also. And there are 2 pods here and there are 3 pods here.
But they have their own specific data amount on a specific node. It is not like same data. It's a different data.
Yeah, folders are with the same name, but now data can be different now.
Actually, it is not the different because of deployment, right? So it's a data will be the same data, but copied into 3 different mount point.
No. The mount points which are created right now as a directory, they are created physically on the worker nodes differently.
I got it. Let me explain. When you create a deployment, you created, let's say, 3 replicas, and each 3 worker node has its own replica pod, and it will also create, if there is directory is not there, it's going to create a directory data1 in each 3 worker node. Now,
Correct.
but they are not related to each other since it's not NFS share, right? It has its unique hard-coded pod with the worker directory, right?
Right.
So
Yes,
now, but it's again, it is again the pods are in relation to each other because it's not a separate pod. It's a replica pod. So whenever the data is writing, the application is writing data, it will copy to all the 3 directory, 3 I'll show the local path, but all the 3 which has its independent data utilization. It is not like something shared. It is copied into 3 directories altogether, but the same data.
I'll tell you one thing.
But how is going to get copied in all the worker nodes?
Yeah, that is what I want. Just let me clarify him that if you, let's say that you have created a deployment, and in the deployment, there are the 2 pods got created here, and they're using this directory /data. Here 3 pods are got created, and they're using this native their directory called as /data. Sorry. Okay, and now if you are writing, if you are using this pod to write something, it will write here only. It will not write here.
But Ramesh, the pods we are not writing to us to pod which are deployed in worker 1. We are writing a pod as a deployment, right? It will be okay.
So
let me ask you this: replicas are not related to. I mean, I'm not writing a data to one pod. It is writing to a deployment.
No, whenever, let's say this is your load balancer, this is service, and you have these pods are there. Okay, sorry guys, this is not coming properly. This is your load balancer here. So when any user request, the request comes, what load balancer does, it sends to the, it distributes to the different pods in the cyclic or round robin method. So when if this pod is on the worker 1, and if it is doing some transaction, if it is writing some data, it will write on the worker 1 directory. If the next request comes and it goes to this particular pod, and if it is you are writing or reading some data here, it will be, the transaction will go here.
Inconsistency will be there in that case.
Inconsistency will be there. Yeah. There is, therefore we cannot use a host path as a production volume host path mount point. We have to use NFS or some other methodology.
Got it. Thank you.
Okay, thank you. All right, guys. So we have completed with this host path kind of stuff. Once we'll come back after the break, we'll discuss about the persistent volume along with the NFS. So let's have a break.
Ramesh, I just have one question. So that means if I have created a database, okay, in container 1 in worker node 1, and another container is there in worker node 2, container 2 database 2, okay, sorry, database 1, okay, because it is the load balancer is going to distribute my transactions, right, evenly between the 2 parts, right? So what does that mean? That, if I have created a table, okay, in container 1, database 1, okay, and if, because the load is high in container 1, okay, another end user is trying to access the same data which has been created in table 1, okay, so if it is routing, load balancing is routing that transaction request, okay, to worker node 2, okay, then he won't be getting the same data. What is it? Because the table doesn't exist, right?
Correct. It is inconsistent completely.
Wow. Then what's the use of doing this? I mean, this is bullshit. Actually, this concept is it's of no use. I mean, load balance is doing its job, okay, but then
guys.
Yeah.
Yes, Sumanta, that's fine. I got it. Let's stop the discussion here. Let's take a break, okay, and once we'll come back, we'll have another discussion of the NFS and persistent volume. Okay, I got your okay, thank you. But one thing is that, guys, because we did this analysis, now you are clear with the volume concept for sure. Correct?
Yeah.
And we are prepared for the interview also.
Right. Yes, thank you. So we will do this
So,
again analysis in when we
yeah,
dynamic.
yeah, please go ahead. Okay. So no, my because this the same question what Vivek asked earlier. Okay, then is that not contradicting with the concept of deployment and replicas? Why? Because we say that you create 5 replicas, and when the dictionary meaning of replica is okay, we assume by default okay that it's same. Okay, it is a mirror image. Okay, but then here we are not getting that, right? Why? Because the at
by using
storage
host
level
path, by host path we are not getting it. Yeah, by using the storage host path we are not getting it, but there are other this one methods are there by which we'll get it. Yeah.
Okay.
So I have underlined the statement that for this host path should not be used for the production. Okay.
So Ramesh, what are the genuine scenarios where it should be used?
Host path.
Yeah.
When you want to specifically use the directory of any node, you can taint that particular node, or you want to in the maintenance window, if you want to use, let's say, local home directory for doing some transactions, at that time you can use it.
Right. Okay. Thanks.
Yeah.
I think you can use it when you have one node. If you use in dev mode like Minikube or other tools in development mode, not in production mode.
Correct. Absolutely correct. When you have one, that is the actually use case for that. But if at all you want to use, if you are training other nodes and you want to store the data at one place only, and then later on you want to resync it, that time also you can use it. But really that won't be used in the, because there are other solutions for that. So host path will be.
All right. Thank you.
Let's take a break now. Yeah, please come back in 10 minutes. Thank you. Okay,
This conference will now be recorded.
Okay, guys. So I have taken this dish, okay, but this is actually a directory, guys. And in this directory, a lot of other ingredients are there. Okay, so think about this, that I want to share this dish with worker 1 and worker 2 because both of them are hungry. So we want to share this. How do you do that? And same content should be there. So in short, whenever I want to share, let's say this is my contents are there inside this folder. Okay, so this is the directory called as, okay, and now there are a lot of data is here, and the same data you want to map on this folder here as well, and the content should be mapped here as well as on this server. So we will use folder sharing methodology whose name is network file system. In short, it is called as NFS. Right, okay? So it is a NFS. So I want to share this particular directory, couscous directory, on the worker 1 as well as worker 2 directory by using the NFS methodology, and then we'll map that to the pods using a deployment, or then we will define the persistent volume, then we'll define the persistent volume claim and everything on this one. But first of all, let me show you how we can share this directory across the worker 1 and worker 2. So for that purpose, you need to install NFS package on the master node. You can use any node for creating these directories, guys. You can create master NFS server here, you can create NFS server here, and both of them can be a client anywhere. And this directory can come
Rami,
from the, yeah.
It can be outside the cluster. It can be in other space, not a master tool, not in the worker master.
you can, this is a storage device which is coming from the outside. Okay, but somewhere you need to mount it, right? Somewhere you need to define that as it is my NFS mount point. What I will do, I will just format this and I will map this to this directory. Basically, in the NFS, mount point normally comes in the cluster. Storage comes from the outside only because you want to keep the data persistent here as well as keep the data safer in case something goes wrong with the cluster. So it will be outside the cluster, right? But storage may be outside the cluster, but you need to map somewhere in the some worker node or some master node. Actual hardware, actual storage box. So what I did, I create a partition of 10 GB and map that 10 GB on the Couscous directory. Now I want to map this directory across the worker nodes. So how do I do that one? Let me set up the NFS server quickly so that we can use it. Now we don't have external storage right now. That's why I'm creating a one directory here and just mapping that directory to the.
This mapping has to be done on the master node, or it can be done any worker node as well. I mean anywhere.
Anywhere, yes. Okay, guys. So let me just please guys hold for some time. I will definitely clear everybody's doubt. So first of all, we need to install the packages on the master server. So these are the packages. This is the NFS master server packages. Since I am a root, I am removing the sudo. You have to use update and you have to install the NFS kernel server packages. So already I have installed. So it is just updating. Everything is cool. Okay. Once this is installed, then you have to use command systemctl enable -- now nfs -server. And I think you need to check the status now and it should be running. Look at my NFS server is running properly. I have started the NFS, right? So NFS package has been installed, NFS server has been started. Now I want to configure it. So how do I configure? What is the configuration file of the NFS? etc exports. This is the name of the file. And here you can tab and you can use the let me use this one, guys. Okay, and I will use here star. So what is the meaning of this, guys? This directory, Couscous directory is, or whatever the directory name will be, can be accessed by all the nodes, and they will, and it is available in the read write mode. Okay, so let me save this one. Star indicates it can be exported to all the nodes. If you want to specifically export to any specific node, you have to give the IP address of that node. Okay, let me save it here. And basically, guys, if it is a cloud setup, in the cloud setup, we don't have the master node available. And if at all you want to do the NFS kind of stuff here, then you can map it to the worker nodes. I am doing it on the master node. I could have done this on the worker node also. There is no problem. Okay. Now another command that you have to fire, this simple command to export it is export fs-ev. All the commands are given in the document activity guide, guys. Okay. And now once this is done, that's it. You just one more time just restart the NFS -server. Cool. So everything is done. This is directory is ready to export. Now I will go to the client side. That is my worker 1 and worker 2. I will install the client package NFS package on the client side and we'll mount this directory over there. So let me go to the worker 1. This is my worker 1, guys. So the package which we need to install on the worker one is nfs-common. I have already installed, okay, because for the saving the time. So now what we want to do, we have to first of all use the command called as the show mount -e, and then use the worker one IP address, sorry, master IP address, because from there only this particular stuff is coming up. So let me go to the master IP address. What is the IP address of my master node? Yeah, this is one. Once this is done, then I will explain you the persistent volume and persistent volume claim, guys, because we are going to use it. So this is available on the client side. Now I will create the same directory called as this one. Okay. And now I need to mount it. Mount -t nfs from this server. Which directory you want to map or mount? This one. And where you want to mount on the local directory also, I am giving the same name. So on all three nodes, on the master node, worker node, and worker 2 node, the directory name will be same, so that when you create a deployment, it should not have a problem. Everywhere it can be same. Okay, that's it. You can see that this is mounted now as a couscous directory. Okay. Now similarly, I need to go to the my worker 2, and on worker 2 also I need to deploy these packages. Oh, sorry, this is worker 1. This is my worker 2. I need to deploy the packages, so it is getting installed. Once it is installed, then you have to use a command called as a show mount. So I will come to know which mount point has been exported. Yeah, this is the IP address of the master node. Cool. Now I will just mount it. I will create the directory, same directory like this one. Oh, I need to be root for that. And done, guys. Our job is completed. Once I create this directory and mount the command mount -t nfs type of the mount point, which directory you want to mount, this directory you want to mount, but where you want to mount on this one. Done. So if I create anything now, if you go to this particular directory on worker 2, what data is available here? The same data which I have written on the master node. Same data is available on the worker 1 also. Understood, guys? And same data is available in my master node also. If I create one more file here, let's say index.html. If I write something here, echo nfs discussion inside index.html file. I have created this actually on the master node. But if you go to the worker node, now you will have the same file here. And you can see the contents of the same file will be same, index.html. On the worker node also, worker 2 also will get the same file whose contents are same. So this is actually major difference, guys, right? So the storage which you would like to map here, it can come from the outside storage. It can be EBS, it can be your anything, guys, anything. You can mount this as an NFS and you can use it. So if you at all you want to, if at all you want to create any disk here and map from the Azure, you can do that as well, guys. Okay. Now, okay. Now the NFS is done, guys. We have installed the NFS server. We have completely done it. Now, so if something goes wrong with my NFS server here as well, my data is outside on some other storage box. I don't have to worry about it. NFS service is the native service of the service of the Linux boxes. Data is in the storage, right? So not to worry. Okay, now this is done, guys. Our NFS is ready. Now we have to discuss about what is a persistent volume and what is a persistent volume claim. So I have one small
Ramesh, one small question, Ramesh.
Mm-hmm.
So related to this one, so we are mounting all the volumes on worker nodes, right? So let's say I have a large cluster and I have like hundreds of worker nodes. Let's say I have 150 worker nodes. So how can we do on all of them at the same time instead of going to one by one worker node and doing this? Is there any way to do that, or this is the only option?
You can write Ansible script for that.
Okay. Okay. Thanks. Yeah.
There is another solution for that as
Mahesh,
well.
just a small question. Yeah, just a small before this. Actually, you created an NFS server and then you accessed it using the NFS client, okay, from the worker. But if suppose like if that worker node which has NFS server goes down for some reason, so other will it be still syncing or that service will be discontinued?
If master node is down, everything will go for the hang condition.
Yeah. So this is
No,
a single
not
point
the
of
master
failure,
node.
Ramesh, right? So we are talking about the node which has got NFS server installed. It can be a master or it can be a worker. If that goes down, then the whole communication, the whole communication goes down, right, Ramesh? So what is the best way to implement or to avoid this single point of failure?
Yeah. So okay.
Have a multiple master.
Yeah. Please.
Yeah.
Yeah, guys. Hold on. Please don't ask question. Otherwise, the topic will not get completed. Okay. But good question actually. We'll discuss about the NFS questions. Okay. So basically,
okay, Ramesh.
yeah, this is related to Linux question. So please, guys, hold on. There are so many alternatives for that one, guys. How to control the NFS server and everything. But we'll discuss about the persistent because if you understand the persistent storage, then that can be taken care. Okay. What is a persistent storage? So persistent storage is nothing but a persistent storage which holds the data permanently. That is the meaning of persistent storage. So from where it can come? It can come from anywhere. From your hard disk, local hard disk, it can come from the cloud, it can come from your external storage also. Okay. So it is like a plugin. Okay, it is a volume basically. PV's lifecycle is managed by Kubernetes. So it is not something related to pod or something, right? It is completely managed by the Kubernetes. And PVs are a cluster resource that exists independently of pod. So even though pod dies, PVs persist. It doesn't get deleted. So who provisions the PVs? Static provisioning is done by the administrator. Dynamic provisioning is used by using by storage classes. Of course, that has to be done by the administrator only. And persistent volume claim is nothing but I will discuss about that and what is the persistent volume claim. So guys, see here, this is a diagram. This is your cluster, and you have storage box, and from that you have created a 2 GB of this one storage, one partition. That partition is called as a physical volume or persistent volume. So this is your another one is created of 5 GB, another one is created of 20 GB, another one is called 50 GB, like this one. So this is your persistent volume, right, guys? So if you have a storage box like this one, a big storage box, right? And this is your enclosure in the storage box. It has a 10 disk which are in the red. Okay, there are 10 disks here. Okay, so what we can create, you can create a partition of 5 GB. And when you create a partition of 5 GB and map this to the one of the node, okay, this becomes actually physical volume, a partition. Now you want to use that partition as a physical volume. So you need to define this as a physical volume, or you need to define this as a physical, sorry, persistent volume. You need to define as a persistent volume. So if it is a disk, hard disk is there, if it is coming from the storage or your local hard disk, operating system disk, and if you have a space there, you can create a partition out of that, and you can create a persistent volume out of it. It is same thing which you are, if you are doing the same thing, if you are bringing up the partition from the external storage, or if you are bringing up the partition from the EBS or Azure or anywhere, it is the same thing, guys. It is a partition, raw partition, which is coming, which can be defined as a persistent storage, or it can be defined as a persistent volume, or another name in Linux language, it is called as a physical volume. Okay, all of them are same. Okay, now. So these are the persistent volumes. Then what is this is called as a persistent storage or persistent volumes, guys, which is coming from the partitions. Now, then what is a persistent volume claim? Persistent volume claim is nothing but, if this is my 2 GB, I want to slice this one, and the slice of is 500 MB, and I want to use that in my deployment cluster. Okay, I want to create a 2 GB slice out of it and map that into cluster as a deployment or as a volume to the pods. So claiming the part of the persistent volume or entire persistent volume, claiming the part of the persistent volume or claiming entire part of the persistent volume by the developer inside the pod is called as the PVC. That is nothing but persistent volume claim. So you have 2 GB, out of that you can ask for any amount, right? Or you can take entire also. Okay. Now I have, let's say, 5 applications: app 1, app 2, app 3. This is my 3 applications running inside the pod, inside the cluster. So first of all, I hope that everything is clear, that persistent volume is nothing but it is a partition which is coming from the storage. Storage can be anything. Okay. Now, if you are taking out the chunk from that persistent volume and using it in the deployment, it is called as a persistent volume claim. Right? Now, the same persistent volume claim can be used in multiple applications also, or you can create a multiple persistent volume claims and you can use in the different deployments as well. Okay, so let me erase this drawing. And we have some explanation here, guys. So this is called as a persistent volume. Now these are the developers want to use this particular persistent volume. So they will take out some chunk out of it. They want to claim it. So they will create some small chunk of outside that physical persistent volume, and then they will define it as a persistent volume claim, and then they will map that into inside the container and will create a pod, and that pod will be deployed inside the deployment. So it is a provisioning and will be claimed by the developers. So binding this PVC to the persistent volume. Okay, so mapping this PVC with the persistent volume is called as binding. So there are two terminologies, provisioning and binding. And it is using, that's it. So there are couple of modes are there, access modes, that you can map your persistent volume claim on one pod also, that is called as read write once, mounted as a read write once. If it is a read only many, that means you can mount the same particular persistent volume claim on multiple pods. in short, multiple containers. This is read only, and read write many is nothing but it can be mounted on multiple containers and it can be read and write as well by many. That is the access modes. And there are two volume modes are there. One is a file system and another one is a block. File system is nothing but a formatted partition by using a file system like ext4, ext3 or ntfs or btrfs, something like that. But block is nothing but a completely raw disk which is not formatted, that can be mounted inside the container. So how do we define this one? YAML definitions. How do we declare the persistent volume, guys? Yes, here I am going to show you by creating it, don't worry. This is my persistent volume. It is a kind, and we can give the name to this PV volume 1. What is the size you would like to define? You are defining this as a 1 GB. It will be RWX, that it can be mounted on many containers simultaneously. And how it is declared? See, NFS, which path? So we will use a cocos, right? Couscous, right? And it will be read only is false. So this is a persistent volume definition. Then what is the definition of persistent volume claim? Look at this, guys. We are saying that developer want to use a chunk of 500 MB here. It is a request coming up, 500 MB. It will be in read write many. And what is the name you are giving? NFS claim. But by any way, physical volume metadata or label or its annotations are not used in the PVC. Then how this persistent volume or how this persistent volume claim will get bind with this one? This is important, guys. This question I am asking you is very important. Anywhere in the persistent volume claim, we are not defining use the space from this persistent volume. But still it will get binded, but on what basis? The reason is that for this particular persistent volume, the storage class which we are going to use or which is by default used is a manual. So mapping of the persistent volume claim from the persistent volume is done based on the storage class type. Please keep this in mind. Okay.
Sorry, Ramesh,
and now this
explain?
So I'm explaining this concept again. So storage class types are different, like manual storage class is there, Azure closed storage class is there. That means the name of the provisioners. So now if you are not specifying any storage class here, that means it is taking as a manual. Okay. So binding of the persistent volume claim. So in short, we are saying that this is my persistent volume and chunk of that persistent volume will be taken by this persistent volume claim and it will be mapped to the container. But what is the link between persistent volume claim and persistent volume? PV and PVC, there is no linkage other than storage class name. If you are not specifying the storage class name, it takes a manual one. Okay. Let me move ahead. I will take the question later on, guys. Fine. So this is YAML definition and how to use this persistent volume claim inside the pod or deployment. It is very simple. We have seen the two words in the host path. One word was volumes and another one word was volume mounts. Volume is the property of the pod, and volume mount is the property of the container. So we are going to map inside the container. See, what is the name? We are declaring this as NFS volume, and from what kind of NFS volume you want to use. This is a persistent volume claim. And what is the name of the NFS claim? This is NFS claim. So this name and this name is same. So what is the storage? 500 MB. So 500 MB storage will be mapped inside this on this particular mount path. Because we are mapping this NFS volume mount and this one is same. So this volume name is called here in the volume mounts, and this claim volume is whatever PVC is mapped with this particular user share engine system. Okay. If you want to use 100 MB or 200, you have to create a persistent volume claim that accordingly. If you want 100 MB, you can use 100 MB. If you want 200 MB, you can use 200 MB. If you want to use 300 MB, 300 MB. You can create multiple persistent volume claims. Okay. Now let us start using this one. Let me now. Is there anything else that I want to explain? Okay, these are some of the important points. Okay, we'll come back on this one, guys. Let's hit it on our deployment. So this is my worker one. Where is my master node? This is my master node. Let's use the okay, guys. Now see, I think most of the questions will get answered when we create our YAML files now. cd/root is I have a standard YAML file, so we'll use that one. PI. What is the name of the YAML file which is using the activity guide for the persistent volume is nfs-pv. So guys, let me use here cp nfs-pv .yaml to the physical volume 1.yaml. So I'm creating just copying the file so that I can modify in the duplicate file pv1.yaml. So this is the name of the volume. So this is a kind called as a persistent volume. Name I will keep it very simple. Let's make it pv1. Simplification of the name makes, and capacity is 1 GB. Let's take the example for 1 GB as of now. And access mode is read write many. Persistent volume reclaim policy is that even though this persistent volume gets deleted, the data which is there inside the directory will be retained, right? So that is PV can be retained, right? The data can be retained. And what is the NFS path? I need to change this one. And what is that? Oh, the different name is there, right? This one. So in this directory we have our data. This is our directory, and which is on the server kubeadm master, or if you don't give this also, that is fine. Okay, but is the same name, guys? kubeadm master. Okay, let it be like this one.
Ramesh, we need to provide us an NFS server path, right? Where the data will be.
Yeah, this is that path. This is that path where the data is there, right? And okay, so let me just comment this one, guys. Let me save this. Host name master. But I'm damn sure that this is not maintained in the etc host file, so this will fail. Is it? If it is maintained, then it's fine. No, it is not maintained, so it will not work. If you give the name, then it will not work. And what is kubectl gate nodes? What is the name coming up?
You can give the IP address, right?
So I think I will use a master here, so that will be understood by all. Let me try out. Even though if you don't specify server, it will pick up, guys, not an issue. So kubectl get persistent volume. We don't have any persistent volume now. Kubectl create -f pv1.yaml. So you can see that it is showing it is created. Yeah, now it is 1 GB pv1 rwx retain and available status right now, but it is not claimed by anything. Storage class is right now empty. That means it is a manual, and age is 5 seconds. You can describe this kubectl describe physical persistent volume called as pv1, and you can see that the path is a couscous, right? And the capacity is 1 GB. It is in the rwx mode. Cool. Now let's write our PVC. Now we have defined the physical volume, sorry, persistent volume. Always this physical volume comes in my this brain because I normally do a lot of things on the LVM and RAID, so that is the reason. Okay, now I need to write a PVC. So what is the file name we have used in the for the PVC? nfs-pvc, if I'm not wrong. Yeah, nfs.pvc. So let me copy this as a pvc1.yaml. Okay, and let me now open this file pvc1.yaml. Right, and the name of the PVC is it is a persistent volume claim is again a kind. API version is v1. Metadata you can use pvc1 here. So I'm simplifying it, guys. pvc1. Read write many, and how much you are requesting? 500 megabytes, right? Let me make it 300 megabytes.
Out of 1 GB, right?
Out of 1 GB.
So Ramesh,
So
sorry to interrupt you, but after this exercise, if you can just draw the in a whiteboard, explain this scenario, it will be really good for everyone.
Sure. Kubectl apply -f pvc1.yaml, and now you can see here kubectl get pvc, and now it shows that pvc1 has been bound with the pv1. Capacity is 1 GB, okay, of the pv1, right? And now is it, and what is the pv now showing? See here, pv, it says that it has been claimed by the pvc1 because their storage classes are same, they are manual. If it is not defined, that means it is manual, and that is the reason it has been. Okay, now let me create one more thing as cp pvc1.yaml to the pvc2.yaml. I'm opening this file pvc2.yaml and just creating another PVC claim and trying to make it of 400 MB. Save this, kubectl apply -f pvc2.yaml. What will happen, guys? It is created.
It will create another. It will create another PVC.
Now see here kubectl pv. It is showing that default is pvc1. Kubectl get pvc. It is showing pending. Even though there is a space, what I want to say that, let me draw the diagram here, guys. This is my physical volume. We had persistent volume, sorry, persistent volume of 1 GB. I have created a first claim that I want this much chunk of the as a PVC1 of, let's say, I think 300 MB, right? I defined it as 300 MB, guys. Now I'm declaring that please create one more PVC and use it 400 MB. But this is not getting created. This is not getting binded with this.
We do have a space, right? 700 MB.
We
This is
have a space
because of
here.
the storage class.
Yeah, storage class. And now important thing is that, guys, you see the PVC and you see the PV also, both of them. In PVC, the capacity we have declared is 300 MB for the PVC, right? But it is showing 1 GB. So even if I define it as a 300 MB, it is taking 1 GB entire space.
That's not good.
Yeah. So what is happening in the PVC to PV mapping? It is a 1-to-1 mapping. It is happening 1-to-1 mapping. Okay. So if I need to, now this is in the pending state, guys. This one is in the pending state PVC2. What should I do? I need to create one more PV and map that there. Then only this PVC2 will do it.
Can't I extend the existing PVC one?
No, that is not allowing. As the default behavior of the Kubernetes, it is not allowing. It is 1:1 mapping.
Even if we extend PV, the PVC which has been created with the first YAML, it will get all the space.
Correct.
It will not.
Correct.
Right. It's 1:1 relation. That's why.
Right. All right, guys. Now let's use this space inside the pod. I think this is very important to understand. Before using this into pod, because when you use in the pod, we are going to use it as a data over there. That is not a big stuff. But did you understand what is a PV and PVC now? First thing that we need to. What are the
Why don't
questions?
we create directly PVC? I mean, what is the role of PV then? I mean, it's a 1:1 relation. Then I think it's a logical entity, and we can carve the space.
Kubernetes doesn't allow that way.
The LVM concept, right? Logical volume manager. LVM concept is like.
I understood. From the Linux level perspective, it's fine, but we are studying Kubernetes. It is not available in the Kubernetes.
Even in cloud Kubernetes also, or is it like a enterprise related, Ramesh, or both of them will have the same PV to PVC mapping?
This is in the storage class called as a manual, but in the different storage class, this is not the case.
Different storage class means?
Okay, storage class are different storage classes. Okay, but I will come back to that point, particularly Abhiram. Just give me 2 minutes. Let me see if any questions are there on the PV and PVC. From where it show? Okay. Anuj is asking, yeah, questions are started from, okay. I can make worker node as NFS. Yes, Vivek, you can make it as worker node as NFS. Yeah, you can make the worker node as NFS also. NFS server node, yes. Vivek is asking, in cloud, we don't have access to master server. That's why we can, yeah, we can do that one in the, so that specifically we can map it to the worker node, or you can mention worker one as an NFS server. Anuj, do we need to have multiple NFS servers to avoid single point of failure? No, as such, right, Anuj? If
So
something is good.
yeah, so if the node that is having NFS server installed gets crashed.
No, if it is getting crashed because of some other reason, okay, then anyway that is going to hamper everything. But as such, NFS is the partition, and if that partition that partition is coming from some hard disk. Okay, in our case, we have just created a directory, but in actual scenario, that partition will come from. So I think I should draw it.
Yeah, I understand the data will not be an issue at all, but because of this server, because the server NFS server is enabling all the nodes to talk to each other, right? And if the NFS server fails, I mean that node goes down, then I think it will be a problem in terms of communication, not with the data, because the data is anyway external.
Yes, yes. In any case, it will be problem. Even if your disk is coming from the EBS or it is coming from the Azure, from anywhere, that will be problem. And if you are talking about the NFS master and server, you creating a multiple NFS servers, that one possibility is there. But again, if something goes wrong with the, then there is a possibility, right? That possibility is there. But how
So
you'll
Ramesh,
map,
in
how
that
you'll
case,
map the client server?
we can have a multiple master also, right? If one
Yes, we
master.
can have. Yeah, we multiple master in the sense you are saying this one Kubernetes master, right?
Yeah, correct.
The
That is
point here
what
is
Anuj is asking at.
no. So point here is this NFS server can be on master or your worker node.
It can be on anywhere, right?
It can be anywhere, yeah.
Right. There is no possibility. So if you, even if you listen to me, even if you create a, even if you have multi-node master, multi-node worker node, still NFS multi-node NFS is not the I think possibility.
There is a possibility for high availability of the worker nodes. Let's say I have one NFS server worker node deployed right now. I have a single point of failure, which I am thinking Anuj is asking, but that's maybe beyond Kubernetes level. But let's say I have one VM which is acting as a worker node, and I would like to. Let me ask you before moving to the next question. Let me ask you this: can you have your deployment for the worker node, replicas of worker node? Let's say one node is down, it automatically creates another node at the Kubernetes level.
That happens.
Yeah, but that will have a bit of a downtime.
That's fine. At least my NFS server, which is created in worker node 1, if it's down or crash, then the Kubernetes will going to create the second replica or maybe second worker node automatically.
But the issue here is that if only NFS server is down, then only it will create a new worker node. That case is not possible.
Okay.
Yeah. So Ramesh, what is the recommendation here to avoid such scenarios?
No, recommendation is that basically what you can do, you can create a multiple NFS mount points. So let me put it this way. This is very actually interesting stuff, but difficult to answer.
Yeah, it's not like black and white. Yeah.
Black and white.
So, but Ramesh, since we have a storage space which is outside, that will be anytime up and running, right? So if a master NFS fail, we can again create one node and we can point it there, right?
No, he's asking that is possible. Data will not be lost. His question is that how that, but if your volume is down, NFS volume is down, their pod will come down. They will go into the pending state. They will get confused. So during that time, if any transactions are happening, your application will be down if your NFS server is down.
Yeah.
Right? That is considered a storage failure, right?
It is not a storage failure. Okay, storage is here.
Yeah.
This storage is mapped here inside the master node or worker node. Okay, and it is configured inside the NFS. This is NFS configuration. And you have a different worker nodes here. And all the worker nodes are using the data which is inside this, data which is inside this particular directory.
Yeah.
Inside this NFS. So suddenly if this goes down, this is there, this is nothing happened with this one, but this NFS server is down, even not master server also. If NFS itself has crashed because of some reason, Master is up and running.
Yeah, got it.
Okay. So that time how to happen. So what is the best way for this one, alternative for this one? That is Anush's question is. Okay. So now, what answer should I give?
We can park it aside, Ramesh. We can think over and come back. That's
So
fine.
you don't have any HA for NFS?
You don't have
any high availability features for NFS?
No. What we can do in this case, I can map here on this worker node the same storage. I can create a NFS mount point here. But the problem is that the name which you have used inside the volumes, it will be different. See, if this is my storage and I have mounted in this NFS server as a slash, let's say data, and same thing is exported here as a slash data here, as well as it is available on this one. Now I want to create another NFS server, right? So if I have another NFS server, so what I will do, I will create an NFS server on this one, or maybe any other, maybe any other worker node, NFS server itself, and I will map this particular storage on so-called NFS server here, and that will be having, let's say, slash data one. Okay, and this I need to mount on all these worker nodes.
There is going to be downtime.
It is going to be downtime, and we cannot use as a same name, because if you are using the same name, then the pod will get confused from where actually I need to get the data. So give me some time. Yeah, if you have a solution, let me know.
No. Can this NFS server be on a pod itself, a separate dedicated pod for NFS server, and if it goes down, it will be brought up immediately by Kubernetes? Will that solve this problem in any way?
But you need to mount some volume inside the pod
Yeah,
also.
that's true. All right,
All
let's
right.
park this aside. Yeah,
Let's
cheers.
park this question right now. This is interesting, but I have not seen this.
I think the good question is this: we need to have loosely coupled, right? I mean, it should not be hard coded or something. Pod is basically used to loosely couple the services, right?
So that is not the solution for it. No. But only thing is that what are the cases of the failure of NFS, and can we have a master and slave concept in the NFS? That is what we need to see only.
Yeah.
If it is there, then this will work. Otherwise, no. Okay. Okay. So guys, any other question that comes in your mind? I think I was taking time.
Can you explain the access modes one more time? I mean, to bring some. Yeah, I think
Let me check out what is Vivek asking. No, Anuj, actually EBS is external. Okay, NFS external storage. Yeah, we can create. Only we don't want any downtime. That was the only thing, right? Partha says NFS service can be implemented in HA. Yeah, correct, Partha. That is the only solution I feel. But again, then you have different set of the servers will be required for the NFS to maintain the high availability. Anuj, I think we have discussed about this, right? Unified storage still use the NFS share which comes with. Yeah, that if that problem is not that data is there, high availability at the storage end is there, Partha, unified storage. But the only thing is that if something goes wrong with the NFS configuration or NFS server itself in the master node or worker node, then how you are going to map it? That is the only question is.
Okay, Ramesh, if we create two PVs with the default storage class and then we try to create a PVC, then how will it understand from which PV I have to get because both are having default class?
Whoever having the free resources, it will go to that one.
Okay.
Right.
No, but the free resources means what? You once you let's say Tulsi has a question. Maybe I'm not whether you have pick up that Tulsi question or not. But let's say you have a three PVCs. I mean three PV, 500 MB, 300 MB, and 200. I'm just picking the question with Tulsi asking. Maybe if you are on that question, then we can discuss. Otherwise, you can discuss before the question which he asked.
Mm-hmm. No, I got your question actually. The question is that you have three PVs of same class.
No.
Right,
The class is same. Let's say I have on the same storage class. I'm not asking the question about storage class, but we have three PV, 500 MB, 300 MB, and 200 MB. Now we created three PVs. That's good. Now we need to create a PVC, and we create a PVC with 400 MB, 250 MB, and 190. But now we cannot create a 400 custom PVCs. Anyhow, if you create a custom PVC, it will going to use the whole space. Let's say you have three PV, 1-to-1 relation. So three PVC will be created 1-to-1 relation. So 400 will map with 500, 250 with map with 300, 190 with map with 200. So in that case, your 100 MB still be available for the PVCs which you created three PVC out of those three PVs, right? Because you have told us it's 1-to-1 relation. That I understand. Now my question is this about the container level. Now I have an application Nginx, and Nginx guy come to my, hey, I need 700 MB of container space, or maybe 200 MB of space, right? I don't have any PVC available for 200 MB kind of PVC. I will pick 250 is much better fit for 200 MB plus container request. So I'll allocate that PVC to that container. But again, I have wasted my 50 MB because again, the request was only for 200, but I have a PVC available for 250 MB. So I have to give that PVC to that container, right? So in that case, I'm giving 50 MB extra. So there is a lot of dependency. I'm not sure how we can correct that kind of dependency.
So there is a concept called as a dynamic provisioning, right? So dynamic provisioning will allow you to resize the space of the PV and PVC. So if you are creating a if you want PV is, let's say up 300 MB and you want more PV, now more amount also, more size for the PVC. If you extend the PV, if it is a dynamic kind of stuff, it will allow
That
you
is
to
fine. Extension, we can increase the PV size to let's say 500 MB was PV size, and I've created a PVC 400 MB. So anyhow we have to 500 MB space available to that PVC. I can got it. But for dynamic provision, let's say you can add more space to that PV to add to 1 gig, let's say. Then that 1 gig, now I have to extend my PVC to allocate that space, or it is automatically available. First question, that okay, now your space is 400 MB, but since the PV size is has been extended to 1 gig, so now you have a 1 gig space available, and the container also get the 1 gig space automatically.
Right, it gets 1 gig space automatically.
Okay.
Because
There's
you are
no
not
reduction. Like if I want to read, I want instead of, if some way we found that Nginx container required 500 gig, no, he doesn't require 1 gig space. Right now it's available for him. That's good. But as an admin perspective, I want to restrict that guy to 200 MB, not to 1 gig.
That
and
we
then
can do. That we can do by using the resource quota.
Ramesh, you didn't answer the question before, and we've gone into a different track just now.
Yeah, but okay, we have to just use up a resource quota. That is what the answer of the question earlier one. Okay.
I think you are yet to explain that, right? How to use resource quota and all that.
Yeah, that is the next topic. Yeah.
Oh, thank you.
Abhiram is asking that persistent volume difference from OS disk. Different. Yeah, it is different. It is actually partition, Abhiram. Okay.
Yeah.
Yeah. Vivek, do you need to provide PV name while creating a claim in the deployment? You have to give the PVC name, Vivek, while creating a deployment, not PV name. Okay. How to decide percentage of PVC from persistence volume? I think we have discussed about this, right, Abhiram? It is one-to-one mapping. It is not coming like that. Vivek says if we have, right. If you have PVC of 500 GB but container is 100 GB, then 400 GB is wasted. So we can apply the resource quota. Right? We can apply, we can use same PVC on multiple containers. No? So we can apply
got it.
resource quota.
So same PVC can be used for multiple pods.
Yeah, we can use that.
You got it. So and on the container level, we can put the resource quota. Thank you.
Right. Okay. How can we do correct sizing, right? Vivek, that I think we need to discuss about the sizing about the PV or PVC. That depends on what is the requirement in your pod, that we can that way you can create a PV and PVC. Okay, but where we manually specify the PVC or PV definition in this case? Partha, you are asking something which where we have manually specified the PVC.
That got answered already. Got it clear.
Thank you. No, in cloud PV there is a different. We can do the dynamic provisioning, Abhinam. Tulsiram is asking, Ramesh, can we create a multiple PVs like 500 megabytes, 300? Okay, you want me to show this one, Tulsiram? Okay. So his question is that create a multiple PVs of different size and create a PVCs of different types and try to check to which one it is getting bind, right? Yes, something like a locking, correct, Venkatesh. Okay. So guys, let's deploy this now. I will create one more PV, but to create a PV, I need to have the again NFS. Yeah.
Ramesh, sorry, but you said it's something like locking. You said that we can use the resource quota to allocate the space or deallocate the space, right?
You can resource quota is nothing but which we can decide. But let me tell you one liner that resource quota is nothing but you can limit the CPU and RAM utilization per container. Maximum.
Okay, but
not storage.
CPU and RAM utilization or storage as well. Yes, storage as well.
Okay, so in that case, like if we have 1 GB of PV and the PVC is required, 500 MB of PVC is required, then we can release the other 500 MB, right? Is that my understanding?
No, you can use one PVC in multiple container. That is what I want to say, so that we can use that for storing the data. But we'll see that how that is possible. Actually, that is also something which need to discuss and see. Let me deploy this practically and see it, guys, quickly.
Sure.
So I think the question is this, that if you have one PV for 1 terabyte and you create one PVC out of 1 terabyte to 500 GB, you cannot create another 500 GB PVC from the same PV. You have to 1:1 relation. I think that's what my understanding.
Yeah, in the storage class called as a manual, this is a permanent, right? You have to create a 1:1 PV and PVC. It is a 1:1 mapping.
But then if you can extend the PVC, okay, by using resource quota, okay, then there is no need of creating another PVC.
For that container, it will be. For that container only.
Okay, so one PVC is used for only one container. You can't share it?
No, you can share it. That is what I'm saying. You can share it. But the problem is that if you are sharing the PVC, that PVC is mounted on the, let's say, now this, in our case, this is mounted here, right?
Yeah.
So if you are mapping the PVC, which is coming out of this directory at multiple locations, okay, so then how the data of the multiple containers all the containers data will reside here, and the data of each containers will be visible on all containers, right? So that is a problem. So you need to define as per the application wise. You have to create the PVC and PV application wise, so that it will not create a security issue.
So that means
I think
the
Ramesh,
data inside containers, so go ahead, Vivek.
no, go ahead, sorry.
What I'm saying is the data isolation between containers, okay, it is getting, the isolation is being created by PVCs.
Right. So what actually need to be done, guys? See, I'll tell you one thing. Understand this properly. This is your cluster. Let's say, let me write from this is your cluster. I'm saying this is a cluster. I'm saying cluster. And you want a different physical volumes. So you may have from anywhere the storage is coming. This is your storage, right? You have to create a partition of this one, raw partitions. Let's say this is 1 GB, this is 2 GB. Okay, and map this partition here on the different folders. So this is for your app 1 deployment. This is for your app 2 deployment. So now what will happen if you create a PVC? Let's say you have created a PVC. Okay, and you have mapped this PVC to this PV. So this is your mapping hole. This is your mapping, right? And this is coming on the different partition altogether. You want to create one more persistent volume, create one more as app 2, create different PVC, bind this one so that it will use the space here, partition, different spacing here. So this way you can do the isolation. But if you say you have created one partition of 5 GB here, and if you have mapped this here, and let's say this is your let's say mount point called as a slash, sorry guys, mount point called let us slash mnt, and now you are trying to map this with multiple PVCs. So this will have a this is container 1, this is container 2, this is container 3. Okay, and you are mapping the same PVC with the multiple containers, then the data isolation will not be there. If this is a different application, this is a different application, this is a different application, then all three applications
No,
will
but
share.
if we have one application having multiple pods, each application pod is having a different application on.
That is fine. If this is application 1, you have 100 of the containers, no problem. But I am having this the containers in the different application, and providing the same PVC to them is a data violation. That means you will not be able to do the data isolation in this case.
I think the point is clear here. Your PVC to PV is hard-coded 1:1 addition, but PVC to pod, there is no dependency. You can mount your same PVC with multiple pods or multiple containers.
Right, correct.
So in that case, whatever Vivek said earlier, that is correct. That once you partition your hard disk, okay, or storage, and map that with a PVC, okay, then you have to design it properly, okay, as per your requirement. Because today is if the architect says that my application needs 500 gig, okay, and you partition the storage like that and mapped it with the PVC, and tomorrow if he says no, I mean we need 600, then that is not possible.
So you can extend
No,
this
600
one.
is possible. 600 is possible. You can extend your PV, right? But reduction is not possible.
But then you can extend the PV. How you can extend the PVC?
No,
it will get you all the space automatically.
Oh, automatically. Oh, that is possible?
Reduction is anyway, it is not, it is Linux based, so you can't do it reduction. Extension is possible.
Yeah.
Oh, extension is possible. Okay.
Yeah.
Reduction is possible in case of cloud, right? I mean, cloud you can, I mean, if the storage is from cloud, you can.
See, if you have a data, Abhiram, you should production data, you should avoid 110% reduction. Never ever try to reduce any data mount point unless and until you don't take a backup. Otherwise, there will be problem. Logically, it is possible. Technically, it is possible. You can reduce it, you can extend it, right? But if you are extending, data loss will not happen. But while having a data inside it, if you are trying to reduce it, there is a possibility that your data will get lost or inconsistency will happen.
No, other thing is, let me ask you this in a better way, Ramesh. If you have one, let's say I don't create multiple PV. I create only one PV with 1 terabyte of size, let's say, and I created one PVC. If I've created 1:1 ratio, so if I created a PVC, whether it's a 100 MB or 200 MB or 1 terabyte, it has to be 1 terabyte, right? Not maximum that. I mean, that's the maximum size right now. We can go with 1 terabyte PVC. I create one
Right.
PVC, it gets a PVC of the same space storage allocation as PV, which is 1 terabyte. Now my PVC is ready with 1 terabyte. Now I'm deploying application. Application means I'm creating a pod. In turns, I'm creating containers. I have one application. I'm using a PVC one, which has 1 terabyte of size. I've created, and now my requirement was, let's say, 100 gig. I have created one application. I have two containers which are using that PVC. I got the space of 100 gig, but anyhow, I have all the space, 900 gig still available to those containers. I can do a quota, resource quota. That's a different story. But let's assume I have, I mean, I cannot restrict at the PVC level because all the space is still available to that containers of pods. All the space which is PVC has, right? Now I have deployed another application in terms basically using the same PVC, and they also have the same storage available, right? 1 terabyte. Now, I both application running and they are using a space. Now some application use 400 gig, other application use 200 gig. Now 600 gig already used, right? Now only 400 gig storage is left over in that PV. Now I have to reduce. Now the architect come, hey, I think these guys are using extra space, we don't should go, let's reduce your size of PV to 500 gig, correct? Now you cannot do that because your dependency that you already have consumed 600 gig of PV out of that. So you can go by 400 gig reduction maybe, right? So you can reduce up to 400 gig size out of the PV. Because the PV, if you reduce the PV size, automatically your application storage utilization will also be impacted.
All right, correct. So PVC will also get impacted, right? Its size will also get mapped to again with the 600 MB, 600 GB.
Isolation is not there on the PVC level. It is isolation. I mean, that's
the partition level only. So partition should be mapped with the PV, and that PV should be mapped with the PVC for the same application.
I think it's better to, I don't know why the PVCs comes into picture. We can directly use PV to create a pods.
Right, but that is not actually allowed here, right? Because whenever we are doing the dynamic provisioning kind of stuff, that in that case you can, and because PVC is required because it is persistent across the, you can use that kind of stuff across the cluster, right?
Maybe we can use that PVC for the multiple applications. That's why the PVC comes into picture.
No, see, the storage is coming from the EBS, and you have applied this storage to the cluster. You can create a multiple PV out of it, and you can apply to the multiple applications. But if you want to increase or if you want to decrease, then how you are going to do that? So if you increase here size here, it will automatically get modification inside the cluster. So that is why dynamic provision is required. PV and PVC is required for, because it is getting across the cluster. Otherwise, you have to again map like PV and PVC, NFS and everything. So that creates a problem. If you're having a storage class get across the cluster automatically. So I don't want to confuse you now, guys. Only thing is that you can create a partition that is called, and you can create a PV out of it, and that PV can be mapped to the PVC, and PVC will be used inside the pod. Okay. That is the only thing.
Yes, Ramesh. Thank
That
you.
is the only thing you can keep in mind right now. Okay. And we will have more explanation on this one. Again, I will come with in the next session tomorrow. We'll have a couple of more examples on the PV and PVC, and we'll close the session. I will make sure that everybody understand this concept before closing it. Right? It is already the time has crossed, guys. So I need to stop here.
Ramesh, I just have one doubt.
Yeah.
Yeah. So, I mean, I still have little bit of doubt on, that applications will be getting the storage from the PVC, right? Okay. And one PVC can provision storage to multiple applications, you said, right? One
Right.
PVC. Yeah. So, and we have, so a PVC can be extended up to the PV limit, right?
It gets automatically extended up to the PV limit.
PV limit. Okay. So in that case, you don't have to provision multiple PVCs.
No, but
Where
that
is
is a
the
wrong
requirement?
approach. This is the wrong approach. We should never ever use same PVC for the multiple application. That is a disaster we are doing.
Why do you think so?
Fundamentally, the data of the one application should not be accessible to other applications.
Yeah. Okay, data isolation. Okay.
Yeah,
A security breach might take place, right? If you use that.
Right. And that.
But we can use
Correct.
one PVC in multiple pods. I mean, multiple nodes, right? Same application, multiple nodes.
Same
So,
right. Correct. Yeah.
So that means
he has a good point, right? I mean, but that is possible. That is not a best practice, but that is possible.
Yeah, that is
So
possible.
multiple pods can use multiple pods can use one PVC. Multiple pods of the same application of the same deployment can use
PVC.
A deployment with multiple pods can use one PVC. Can they?
Yes, we can use. Yes, we can use one PVC for multiple pods which are in the same application.
Thank you.
Yeah. So that means that while designing an application, okay, better you should be 100% sure, okay, that you know how much storage you need for your application, so that you can have that partition in your storage.
Yeah, that you know, even though you create a less partition, that is also fine. You can extend it later on.
Yeah,
so you can extend the PV. You can extend the PV.
Yes.
Okay. Yeah.
Dynamic
otherwise,
Ramesh, we need to. I mean, Sumanta has a good point. If you have a requirement, custom requirement to use a application which is like a 750 MB or 750 gig size of requirement of storage. I don't have any PV which has a 750 gig of storage allocated in PV. I don't have any PVC available which has a 750 gig. I will go with the either I have to ask the admin or maybe whosoever that create PV first and then create a PVC and give me that space. I cannot use the predefined PV and PVCs, right, for the custom requirement. Otherwise, we'll go to waste our resources, storage.
See, the one line I am telling you that in case you have created one partition of 1 GB, you have defined it as a PV, okay, and you have allocated as a PVC and you have deployed in the application. If tomorrow if you require 2 GB of the space in the same PV, you can extend the PV. So you can extend the partition, automatically it will extend the PV, automatically it will extend the PVC.
Yeah.
Okay, sure.
Got it, Ramesh. But then somebody asked, and you also responded that if data reduction needs to be happened, okay, make sure you don't reduce the data or the storage, okay, with data inside that storage. Okay, so better if I am having an application, okay, which is having 5 replicas, okay, and I want to decommission, okay, one of the containers, because instead of 5 now I should be using 3 replicas. So the data which is consumed by the other 2 replicas, that can be that I want to reduce. So in that case, I can reduce.
No, that is not the right way, Sumanta. But
okay.
Basically, you can have, let's say, even if you have 5 replicas, let's say, of one application,
right,
they will be using the same data.
Yeah. Right. Okay. Or you can say, if I can put it this way, let's say you have inside application. Okay, if you have five.
Let me tell you one. If you want to reduce the space, okay, there is a partition, and if you want to reduce it, so best practice is that take a backup of that partition. Okay, take a backup of that partition, shrink it, whatever the way you want, and then you restore it.
So what is the difference between shrinking and reducing?
Same. Shrinking and reducing, same.
Okay. Got it, Ramesh. Got it. Yeah. So better be in the safer side to be in the safer side, because if you lost the data, then there is no way to recover. So yeah, got it. Thank you.
All right,
Ramesh,
guys.
it's a basic question. Just I'm asking that. It's a storage is present on the it's an external storage, or it's on the cluster. I mean, on the same node.
It is external storage mapped to the cluster.
Mapped to the cluster. Okay. So here, when we are doing the partition 1 GB and 2 GB, so when you do the creating of the PVC, so the PVC was creating on the pod level or worker node?
PVC is getting created at namespace level. That means cluster level.
Cluster level. Okay. So here we can, once you create a PVC, so it is created on the cluster node, cluster level, and that is going to be mapped or mounting to the container, right?
Correct.
Okay.
Absolutely.
Yeah. Thank you.
Thank you.
Thanks, Ramesh. Good night.
Thank you very much. Enjoy, guys.
Thank you very much, Ramesh.
Thanks, Ramesh.
Thank you so much.
Ramesh, you put the history, the command history.
Yeah. Okay. 1 second. I don't know from where it has started. All right, guys. See you tomorrow in the evening, Indian time evening, and tomorrow morning who are there from the outside. Yeah. Oh no. All right, guys.
Thank you, Ramesh.
Ramesh, quick question. So tomorrow is going to be a daylight saving. So will it be 1 hour before in UK timing?
No, it is same timing as per that. Yeah.
Yeah, to answer this, Atul said that there will be no changes in timings. It will be an same Indian timing.
Yeah, so Indian timing same, but UK will be changed then 1 hour
Yeah,
earlier then.
either you'll be 1 hour ahead or 1 hour back. That's it.
Okay, cool. Thank you. Yeah, cheers.
We are happy that we don't have changes 1 hour later.
Oh, it's a big problem. It's a big problem. I've set up some test scenarios to check the schedules for a bank. So yeah, good. We don't have this in India.
All right,
Cheers,
guys. Take care and enjoy tomorrow's Holi. Thank you. Bye, guys. Take care.
Yep. Thank you.
Thank you,
Thank you,
Ramesh. Good night.
Ramesh.